Hello again. Today we're going to take a quick look at the Scratch tool. It is a web-based coding platform to teach students the kind of the initial logic behind coding. What's really nice about Scratch is kids don't have to worry about, or even teachers really for that matter, don't have to worry about the very specifics that can come with coding, like making sure semicolons are in the right place, or making sure things are spelled exactly correct, or things are capitalized or not capitalized. Scratch implements a cool way of coding. It's actually caught on, and they've called it a coding language called Blockly. Called that, you can kind of see in this example here, there's a bunch of pieces that look like blocks, and these are pieces of code, and they even snap together in the tool. And students can edit some of these other smaller pieces to change how that works. But you can see a lot of the things are kind of set in place. This was developed by MIT, I believe, and I think that's even in the URL. It's a free tool to help students kind of get into computer science and specifically software development and coding. And I believe they have other lessons built into this. Is a huge website with lots of resources to get started on just about any level. And I think they even have some place where you can do this. They have lessons pretty much K through 12. But it is kind of sort of pointed towards the younger audiences. A lot of the kids I've worked with usually learn this Blockly language, and after a while, they're just involved in their own projects. They're totally engaged, and they're just totally focused. It's really fun to watch. I've worked all the way down with third graders to this at this current time, and they've been able to grasp it. We'll go ahead and start into a blank project here. Let that load. What's nice is even though this works in Chrome, because this works in Chrome, this will also work on a Chromebook or pretty much anything that supports Chrome. So it works within other web browsers too. Chrome is just a personal choice for me, but I find it's the most stable. But because it does work in Chrome, it will work elsewhere. Go ahead and close some of these other ads. Looks like they've always got different promotional events going on. This is kind of the initial page. You can see you have a section down here for sprites. You can add more sprites. Sprites are these little two-dimensional shapes. You can have, a cat, and there's a whole other section, I believe, here for new sprites. Choose from the library. You can upload your own. You can paint one yourself. You can add pictures, different shapes that will bounce around in here. We're not going to get into that too much today. We're just kind of going through the basics to see how this works. Different stages with different backgrounds. If you think of how most games have a level system, I believe that's what this is used for. You can have a level 1, level 2, and kind of progress through if you want to kind of do a game. Or I've seen projects where students will make stories with this. A real popular one that's on YouTube is a student that made a report about Vikings, and a little Viking goes across, and then he runs into a wolf, and then he tells a little bit of a story and goes on to the next part and tells a little bit more about the story. Pretty inventive way to use this. We'll go ahead and dive into some more of the tools that we see here. As I move my mouse around, you can see this XY is changing to show the exact XY coordinates where my mouse cursor is. Over here, the sprite also has its own XY. You notice it's at 0, 0 for the center of the screen. And as I move it around, its XY coordinates will change. Go ahead and revert back to that. Start at 0, 0 here again. So, great way to teach and introduce that concept of coordinate planes and kind of how they work. We'll go ahead and get started. You have a lot of sections for different blocks of code that do different things. If you want your code to make sound of some kind, or change its costumes, they have little costumes, or say things. You even have sensing here's like this touching. This is a useful one because as is, if I just made my sprite move forward, it would eventually go off the screen, and the students have a hard time bringing that back without resetting their code. So a lot of times we set up that if it touches the edge, it needs to rotate or do something so that it always stays inside. We'll just dive right in here and get started. I'm going to hit this control section, the events section. This is a great place to start. That when the green flag is clicked is what's going to start our code. You notice this green flag here is what starts the code, and the red obviously will stop it also. You also have other triggers like hitting keys and stuff like that. So this is a simulation right here. You can see I just drag this over. It doesn't matter where I drag it, it's just going to drop in this workspace and be ready to go. So when I click, I want to say just move 10 steps forward. You can see my shape, there's a little divot right here that matches this peg, and it kind of symbolizes that these two pieces of code are meant to go together. I'm holding down my mouse and clicking. As I even float next to that, that white line shows up, kind of prompting the user to say, hey, do you want this here? And when I let go, it snaps right to it. This number is even changeable. Right now it says 10 steps. I can change it to 20 steps instead. And we'll see what that does. So you saw him move just a little twitch there. The code executes really quickly. If I were to click this flag again, he would just keep going and executing that program over and over and over again. You have to kind of move him back before he goes off the screen. That's what I was saying earlier about the sensing here. It's nice to be able to trigger that when he's touching something to do something else, and we'll look at how to do that here in a second. When I was talking about the logic of code, this control section is a great introductory to that. It can repeat code forever. If I take this in here, take this to the side, attach that. So what I've just created is an infinite loop, so that when I click the flag, he will move 20 steps at a time over and over and over and over again forever while the program is running. Or I can use, instead of those loops, a forever loop, just have it repeated so many times. Instead of having to put 10 of these in, I just change that number to 10 and it'll repeat that code a number of times. If-then statements are really huge in coding. When a condition is true or not true, do something else. You notice the shape that's in here is this kind of diamond shape. Well, that matches these. You notice how I have these pointed edges. Those are designed, MIT's done a good job at kind of showing, like, I can't take the touching and block and add it underneath here. That kind of code doesn't work and it would just cause errors. So they've designed it to where these are kind of draggable in here, and you notice those white lines show up again. So I'm going to put in here that if touching an edge or an edge of the screen here in his area, then I want him to turn, or do I want him to point in a direction? We'll make him, we'll just make him turn. Let's see, from here it would be 90 degrees, he would be pointing straight up. So we'll do a little bit more than 90, so he kind of goes diagonal off to the side. Let's just do an even 120 degrees. He'll turn if he's touching an edge. I'm going to put my 20 steps here. Actually, let me go back to that forever loop. I say repeat that forever, move 20 steps, and if he's touching an edge, rotate 120 degrees. That way he'll always stay contained within here. Let's go ahead and test it and see if it works. I haven't really tested this before making the video, so I'm just kind of creating as I go to see how it's going to work. I'm going to click my flag, and yes, you notice he moves 20 steps at a time. He got stuck in a corner there because the code's just going to keep going. But every time he hit that edge, he rotated 120 degrees. So I'm going to stop the code, move him over to a different spot, and maybe I'll change this to something a little bit more drastic, maybe just a full 180 to see how that changes it. And he'll instantly get stuck in a corner. And this is what's nice, is your students will have the opportunity to experiment with different settings and play with it a little bit, which is really great even for younger kids to learn how to do. Looks like 145 will work a little better. The corners are kind of tough, but he looks like he works his way out of it. But he'll always stay within there. So that's why I like to include that touching edge thing whenever they do something, so he doesn't completely leave the screen. You go ahead and stop that, bring him back. Some other operators in here. This has to do with more logic, if this is true, or if this or that is true. Greater than and equal thens are in here. Let's reduce this steps down so he moves a little slower. Let's just do 10 steps and see how that works. Notice not quite as quick. You can kind of see what's going on a little bit better. Let's continue to see and poke around in here. So we can make it where he will turn 145 degrees. Let's make some kind of other statement, true or not true. The sounds we could add in here, you wouldn't hear it in the video because they would just be played into my headphones, but this would be playing drums and stuff like that. You could have multiple characters that when they hit walls or do something, they'd play sounds and make music. I believe the pen will also draw. This might be a good one to use. Oops, I probably want pen down, actually. I want him to put his pen down at the very beginning. Right after it's clicked, I want to change the pen color, or set the pen color. Oh, I see what it's doing. It's letting me choose from color. I've clicked on it and it's letting me choose a color on the screen. So we'll stick, yeah, with the screen color I can pick here. You can even change the pen color slightly to make a kind of a gradual change. Let's go ahead and play with that. So that every time he turns, we'll change the pen color a little bit and see what we end up with. And pen size, stamps. Actually, I'm going to put my pen down to be right after too, so that it just continues to do that over and over and over again. There's my line. Every time I rotate, you can see it's going into a bit more blue. Now it's purple. And that color is gradually changing. Looks like every time he collides, he ends up making some kind of star. That's kind of neat. So yeah, fun, really, really basic way for kids to mess with code, the logic of coding. There's other extensions and stuff you can add to this. To save your projects, I didn't sign into Scratch. I can't exactly remember my Scratch account, just wanted to show you how to get started. If you wanted to do a full project where you wanted your students to save their projects, something that they would work on for a week or two, you would have to create Scratch accounts. Right now, Scratch doesn't look like it supports, at least that I've found, signing in with something like a Google account or something. Really enjoy using Google accounts with students because then they don't have to have accounts everywhere and teachers don't have to worry about creating accounts. But Scratch homepage did have a link for educators I haven't looked into yet. Maybe they have something for teachers to be able to manage a class or a full class that way, but as it stands right now, it looks like you would have to create accounts, or your students would just have to quickly create accounts. So you want to make sure you keep track of that with your local IT department. And just poking through here, some of the other sprites you can add. I can add a flying cat. So now you see I have him and I have him. You can tell that you assign code to individual sprites. So sprite 1 still has the code I added here, but the flying cat doesn't have anything yet. So we'd have to add code to him separately. But anyway, that's the real basics of how that works, how the Blockly language works. Code.org also uses a language similar to this to teach kids code, so it's just very, very useful, this Blockly language. There's even some projects where they're trying to work with this and Arduino boards and make block robots to code the robots themselves and get the robots to move so that the kids don't have to type it out. Some of the younger kids that might have trouble with the punctuation and keeping all that straight. But anyway, that's the introduction. I hope you enjoyed it. Thanks.